So we're going to continue with sum, difference, and product formulas. Is Yanga raising up his hand? Do you have any question, Yanga? Any question from Yanga? Okay.
Sir?
Okay.
I wanted to know whether the session was paused because, like, the internet, I had a problem with the internet, so I was kicked out.
Oh, no,
Yeah.
we only had a break.
Okay. Thank you very much.
Yeah. Okay. So we continue. Now we have the following formulas, and you need to understand what each of the formula will be used for, okay? One, we use sine and cosine formulas for products. Product means when you multiply sine and cosine, okay, you have a formula for that. When you're multiplying cosine and sine, you have a formula for that. Please, you need to note the signs, okay? The signs, positive and negative sign. You need to take note of that. And when you have cosine multiplied by cosine of another angle, you have a formula for that, and multiplying sine with the sine of another angle, you have a formula for that. Okay. So you also do the same when you're doing sum and difference of sines and cosine. You see the formulas are here, and we're going to be applying this same formula to solve some exercises. Look at the first one. We want to derive the product formulas. Okay. How many formulas are we considering? We're considering 4. The first one is sine alpha cos beta. Second is cos alpha sine beta. Third is cos alpha cos beta. Fourth is sine alpha sine beta. All right. So what I'll do is to derive sine alpha cos beta, and then you should derive the remaining product formulas on your own. You're going to use the same method that I would be using here to derive the first formula, sine alpha cos beta. And look at the right-hand side. We say sine alpha cos beta is half into brackets sine alpha plus beta, okay, plus sine alpha minus beta. Sine alpha plus beta, okay, using product rule is what? Did I say product rule? No, not product rule. Using addition formula would be this. Remember, when the first part of it, let me just circle it. This first part, this implies this. And I said that is by addition formula. Okay? And similarly, you have sine alpha minus beta to be this by subtraction formula. Okay? And therefore, we're going to have, when you solve this, you have it to be 2 sine alpha cos beta. And can we all say that directly? Let me just write it out. Sine alpha cos beta plus sine alpha cos beta. That's what we are summing, which is this. Right? And then this plus this. No, you cannot sum it that way. What you do is express it, write it out completely. So you can see the one you want to add together and the one you want to subtract from each other. So this will be cos this will be 2 sine alpha cos beta. Let's go back. I want to go back to the formula we used initially. Okay, it's this one. Where is it? We're considering this part, right? Subtraction. Sine alpha cos beta, cos alpha sine beta. And this, another cos beta, this is wrong. I expected someone to point this out, but no one pointed it out. That means you guys did not go through this lecture notes. Look at sine alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta, right? Now look at what I've written here, and nobody pointed this to me. Here. This is wrong. This part is wrong. This. By addition, sine alpha plus beta is equal to, let me just write out the correct. It's equal to sine alpha cos beta plus sine alpha cos beta. So this is the correct one. Okay, then you add it to this part. And then by the time you add, you're going to have this as the final answer. Please, can everyone just solve and see that you've got 2 sine alpha cos beta? Solve for sine alpha plus beta plus sine alpha minus beta. I will give you 3 minutes to do that, please. I want you to all get the same thing because this is wrong and nobody pointed. That means you guys have not been following. Just solve sine alpha plus beta plus sine alpha minus beta. See if your answer will be 2 sine alpha cos beta. I'm giving you 3 minutes to do that. Okay. So please correct this part in your notes. Correct this part in your notes. Okay, so since all of you, some of you have got the same answer, I think we can proceed. Please correct this part in your notes. This part is wrong. This should be here. Should be sine alpha cos beta. Okay? Please correct that in your notes. Yeah. Okay. Now, therefore, you have sine alpha cos beta to be what? To be equal to half. Remember, this is 2 sine alpha cos beta. And this is coming from here. It's coming from here. Right? So we mean sine alpha plus beta plus sine alpha minus beta equal to 2 sine alpha cos beta. So if you divide both sides of the equation by 2, you will have half sine alpha plus beta plus sine alpha minus beta to be equal to sine alpha cos beta. Do you all get this? Do you understand? If you don't understand, please indicate. Do you all understand? Because you will be deriving the remaining product formulas on your own. Okay. So let's derive the sum and difference formulas as well. Okay. Let me just write the sum. This is what we want to derive. Sine A plus sine B equal to 2 sine half A plus B cos half A minus B. Okay, that's the first one. Let me write it here. This is what we want to derive. Sine A plus sine B equals to 2 sine half A plus B cos half A minus B. Oh, sorry, minus B. Okay. So to derive this, first is to assume alpha plus beta equals to A. Remember, we're having A and B represented here. So let our A be equals to alpha plus beta and our B to be equals to alpha minus beta. Why are we making this assumption? Because we want to derive the sum and difference formula. So we have a sum of two angles, we have the difference of two angles. Sum of two angles to be represented as A, difference of two angles to be represented as B. And therefore, we're going to have alpha to be half A plus B, okay? And beta will be half A minus B. Now, let's prove. From the proof of our product formula, we have that sine alpha plus beta plus sine alpha minus is 2. Remember that part, which I told all of you to show this part. Okay? Remember this from our product formula. Then this becomes, since alpha plus beta is A, has been represented as A, then this becomes sine A plus sine B will be equal to 2, okay, sine, and alpha is half A plus B, half A plus B. You're just substituting, and that's all. And that's how we have shown that sine A plus sine B is equal to this. We have actually shown from our product formula. So that's it's straightforward. It's a simple way of showing it, but you need to practice. So for you to practice, I've said derive the remaining three sum and the remaining formulas. So you do it using this same approach that I've used. Okay, this may not be necessary because you only need what you need here is to have those formulas, preferably for me, offhand, okay? Because you would need them later in so many cases, especially in engineering. And if I'll give you the formula sheets to show this, what about you want to solve other questions? And you may not have the formula sheet in that case. So for me, I usually advise students to put these formulas in memory and just use it as the case may be. And how do you have it in memory is to constantly practice with these formulas. All right. Okay, so let's look at this. We want to express cos 110 degrees sine 55 degrees as a difference. What do we mean by as a difference? As a difference is using the difference formula. Okay, so if you recollect, the difference formula is now we want to have cos 110 sine 55 as a difference. Here we have in two different functions, and we want to use the difference formula for it. It's simply, let's go back to the difference formula so you see. It's not like I'm saying it offhand. For instance, sine alpha cos beta is equal to half sine alpha plus beta plus sine alpha minus beta. Otherwise, if you want to have the full, this is it. So you have, this is one, this is the second, this is the third, and this is the fourth. Please note, sine alpha cos beta is not the same, is not equal to, or is not equivalent to cos alpha sine beta. Please take note of that. Okay, so let's go back to our exercise. Now we have cos, let me write it here, cos alpha sine beta. That's what we are representing. So what is alpha? Alpha is 110, beta is 55. And using the product formula, we have it to be half sine alpha. Let me just write alpha so you don't confuse yourself. Alpha here is 110, while beta is 55 degrees. Okay. So substituting these values into the product formula, you have this, right? And this. And you can leave your answer this way. Otherwise, you want to solve it further and put your answer in the simplest form, whichever way you prefer. Or if you have it this way, you have your full mark. Let's look at question number 4. Express sine 70 minus sine 20 as a product. Let's go back to our formula. Here you have sine 30 minus sine b. Okay, this is the formula we're using. Sine alpha is 70. Let me write it. Alpha is 70 degrees. Beta is 20 degrees. Okay, so you substitute these values into the same sum and product formula, and then you get your answer this way. Okay? And if you look at it carefully, you're going to be leaving your answer as product using difference rules. And using product rule, you're leaving your answer as difference. It's just an observation. And that's actually a way to check if what you have done is correct. All right. We go to sine and cosine rules. I'm sure most of you are familiar with this. When we say law of sine, and then the law of cosine and all of that. So in any triangle ABC, let's have a triangle. A, A, B, C. A, no, A, B, C, okay? Now, the ratio of a side and the sine of the opposite angle is a constant. This is what we mean. When you have the ratio of one side, let's say we're picking this side C, okay? And the sine of this opposite side, this side, okay, is always a constant. That is A, this is A. I think this should be A. I've not represented this correctly. This is A, this is C, this is B. So this A over sine A is always equal to B over sine B, which is always equal to C over sine C. That's what we are saying. And this is basically the law of sine. A over sine A equals to B over sine B equals to C over sine B. Or you can put it the other way around. Sorry, these are small letters. These are not correct. These and these are A, that means B, B, and C. Sorry about that. Please correct this in your notes. Sine A over A, sine B over B, sine C over C. The rule may be used only when one side and any two angles are initially given. You'll see that in your example. Suppose you're giving one side and you are giving any two angles, then we can use this law of sine. And in the other case, if you have given two sides and you have one angle, which is not the included angle, then you can use the law of sine. You'll see that in our example. Please correct that part in your note. Then the law of cosine. The law of cosine is also straightforward. In any triangle ABC, like we have, in any triangle A, B, C, the square of any side, let's say this is A, side B. So the square of any side is equal to the sum of the squares of the other two sides. Okay? Minus, diminish, that's minus twice the product of these sides and the cosine of the included angles. You all know this. I'm sure you're familiar with this. So this is the cosine law. And we will always use this to find, we always use this when we're given two sides and the included angle. Okay? Remember, for sine, you will not be given the included angle. But for cosine, you will be given the included angle and two sides. Also, when you're given three sides and you're not given the angle, you can use the law of cosine. All right, we'll see examples now. Here in this example, we have the triangle ABC, and we have been given how many sides? We have been given only one side and two angles. So what law are we going to be using? Can someone tell me? Can someone tell me what law are we going to be using here? Thank you, sine law. So that's why we say you should just take note of the cases. Okay, so we'll be using the sine law. And to use the sine law is straightforward. We have been given angle A, angle B, angle C, but we have not been given angle B. Okay, and this is angle B, which we don't know. So to obtain angle B, we simply do sum of these given angles, okay, subtract it from 180. That is the basic formula you use here. It will be 180 minus the sum of the two angles that have been given. And in that case, we obtain angle B to be 25 degrees 30 seconds. Please solve that yourself and see you've got the same answer. Now, we want to obtain the sides, the other two sides of this triangle. We have been given only one side of the triangle, which is A, to be equal to 62.5. How do we then obtain B? From our sine rule, we have that A over sine A equal to B over sine B equal to C over sine C. Okay? Now, we're looking for what? C and B. And we've only been given A. So simply what you do is you put A, 62.5 over sine A, which is sine 42 degrees 10 seconds, equal to what? Have we been given B? We have B. We're looking for side B over, what is the angle B? No. Angle A is not 42. Sorry about that. This is not. I'm doing A over sine A. So it's sine 112 degrees 20 seconds over B, equal to B over sine B. Sine B is, we've obtained B as 25 degrees 30 seconds, okay? Now, by the time you solve for this, substitute, do a cross wherever, B will be equals to 62.5, right? Times sine 25 degrees 30 seconds divides by sine 112 degrees 20 seconds. That is what I've done here. I just wrote this out. I wrote this out so that you can see it. So from here, we can come here just to obtain B. And B is obtained as 29.1. Please work that out yourself. And to obtain C, C will be equal to, from this formula now, let's just do C over sine C. Sine C is 42 degrees 10 seconds equal to, we can use B, we can use A, whatever one. We have A is 62.5 over sine A, sine 112 degrees 20 seconds. You do this, and then you obtain from here this. Is that clear? And we have C to be 45.4. Is that clear? Do you have any question? Do you have any question, please? Can I proceed if there's no question? Okay. Just note that sine 112 degrees 20 seconds, I've used the reduction rule to reduce it to 67 degrees 40 seconds, okay? So that's what I've done. If you get confused, this is just what I've done. And yeah, I think I can continue. Let's look at the second example in this case. We have two forces, 17.5 and 22.5 lb, acting on an object. If the directions make an angle of 50 degrees 10 seconds with each other, find the magnitude of their resultant and the angle that it makes with the larger force. Okay, I've drawn this out so that we can easily see a pictorial representation of it. We have two forces, 70.5. This is 70.5 this way, and the second force 22.5. Okay, both forces are acting on a object, and we have been told that their directions, sorry, I'm using this, their directions make an angle. This is the angle of 50 degrees 10 seconds. All right, this angle with each other. Now we're told to find the magnitude of their resultant. You all remember resultant force, and the magnitude will be this. Let's just put it this way, and that is B in this diagram. Okay, so in the parallelogram, we have created a parallelogram. So I have AD, AB, then DC. Remember, these sides will be equal. C is equal to 22.5, and these sides are equal. Okay, so in the parallelogram ABCD, angle DAB, which is 50 degrees 10 seconds, plus angle B. And what is the question? Find the magnitude of their resultant and the angle that this magnitude or the resultant makes with the larger force. Okay? And the larger force is C. This is the larger force. C is the larger force because its value is 22.5. So we want to find the angle that the larger force makes with the resultant, and that is angle B actually. Okay, so we're saying the sum of DAB at angle A plus angle B should be equal to 180. And that is all we need to know. So we're going to have our B, this angle, to be equal to 180 minus 50 degrees 10 seconds. And that's how we obtain B. I hope you understand this. What I'm saying is 180 minus D is it D now? Minus D I just want to write it in a clearer way for you. 180 minus D equal to, minus D equal to BCD. BCD at angle C. Do you understand this? Should I take it again since everyone's quiet?
Please, sir.
Which parts don't you understand then? Which part do you want me to emphasize? I'm waiting. Angle DAB, okay? Kernel says angle DAB. Angle DAB, like I've described it, and from the question, it says if their directions make an angle of 50 degrees 10 seconds with each other. So this is a force A, okay? And this is the second force C. Force A and force C makes an angle of 50 degrees 10 seconds with each other. And that's what I've drawn here. Okay, that shouldn't be confusing. And now, you were told to find the magnitude of their resultant. What is the magnitude of these two forces? It's just the resultant force. Okay? And that would be, we have not actually got there. We've not solved for that. I actually started by finding the angle that it makes with the larger force. I've started with this second part. And I've not yet found, I've started with this. Okay? I've not yet found the magnitude of their resultant force. Okay? So let me take it again. To find the angle that the resultant force, we all know, you draw the line, which will be between the two forces, and we say that is the resultant force. We're saying, what is the angle that this force, the resultant force, makes with the larger force? And in this case, Keno, what is the larger force between the two? Yes, it's 22.5, which is the larger force. So we want to find the angle that the resultant force makes this force 22.5. In that case, if you resolve this, I don't want to mess up the diagram, so let's use this one which I've drawn initially. If you resolve force B with force C, it's going to make an angle at B here. Remember that this side and this side are parallel. This side and this side are parallel. So we are, if this is parallel to this, so this side is 17.5, this side is 20. Then there will be, this is the angle that we are looking for, which the resultant will make with the larger force. Okay? And then how do we obtain this angle? And that is what I've said. To obtain that angle, we already know DAB. Where's DAB? DAB to be 50 degrees. Then you're adding DAB to angle B. This is angle B. And that must be equal to 180. So what I'm saying is DAB plus B will be equal to 180 degrees. And in that case, we can also say BCD, because of course it's the same. Okay, BCD plus D. This is D, this is B, don't confuse it. This is D. Will also be equals to 180 degrees. Okay, so which of the angles do we know already? We already know DAB to be what? 50 degrees 10 seconds. Then we're looking for B equals to 180. So B will be 180 minus 50 degrees 10 seconds. That's what I've done. Keno, I'm waiting for you to tell me if it's clear. Okay, so we can proceed. So we still need to find the magnitude. Okay, remember we have two questions here. One, find the magnitude. This is the one. Let me just highlight. Okay, I'll pause after. We have two questions. One, find the magnitude of their resultant, and two, the angle. So we've obtained the angle. You may want to use another approach. It's fine if you know, if you can. So we want to find the resultant force, magnitude of their resultant. Okay, and we will be using the cosine rule, and that's because we have been given the angle. Let's go back to cosine rule so that you refresh your mind. This is the cosine rule. When can we use the cosine rule? One, when two sides and the included angle are initially given, or three sides are initially given. Okay, two sides and included angle, or three sides are given. In this case, what do we know? We already have two sides given with the included angle. Okay, so we can easily use our cosine law, and that is, what sides are we looking for as the resultant? Is B, this. Let me draw this out again. I'll clean this so you can see. Okay. Now I want to draw the triangle itself. We have this angle to be 129, 50 seconds. We have this A to be 17.5. We have this C to be 22.5. We're looking for this. Can you see it? So we're looking for B. And to obtain B from our cosine is what? Plus C squared minus 2AC cos theta. That's it. B squared, A squared plus C squared minus 2AC cos B or cos theta. Okay? Let me write it as cos B. Right? So this is the formula we're using. So simply substitute the value of A here, the value of C, the value of A, the value of C, and your angle 129 degrees 50 seconds here, and you obtain your B. That's what I've done. Okay? I will clear. If you have any question, please ask. Sorry, I want to go a step back, okay? And the step back is, the question says the angle that the resultant makes with a larger force. It's not this angle. I mean, it's not this angle. Sorry about that. It is this little angle here. Let me indicate it. No. It is this angle. Yeah. So put it here. This angle. Sorry about that. This is the one we're looking for. We're giving all of this angle to be 50, but we need this little angle that the resultant force makes with the larger force. Sorry about that. It's not this angle. It's not angle B. All right. So we had to compute angle B in order to use our sine rule, our sine law. That's why we need to compute this angle B. And we can compute angle B because we know DAB plus AB, plus B will be equals to 180. DAB plus B, this angle, will be equals to 180. So since we know this, we can obtain our B. And thereafter from B, we can obtain this little angle. And how are we going to obtain this little angle? It's simply using our sine rule. Remember that we have two sides given, three sides now. We already know our B. Let me just go there and show you. So this is what I'm saying. It's angle BAC. BAC. That's the angle. Sorry about that. It's this little angle that I'm looking for. So applying our sine rule, we already have our angle B, we have our side A, and then we have computed our side B, which is this side, which is the resultant force of the two forces. Now, when we substitute that into our sine rule, we obtain that little angle that the resultant force makes with the larger force to be equals to 21.4. Here, what we have done is we have used 1, We have used 1, sine law, and here 2. We have used our sine law. Okay, that's all we have done in both cases. I see a lot of people leaving. What's happening? I want to stop the lecture at 1. So quickly we'll consider area of a triangle. We have a triangle ABC and we want to obtain the area of this triangle. The area I've represented as K of any triangle equals to 1/2 the product of its base and altitude. We all know that from our primary school. Oh, you have J altitude at 1. I really don't want to continue from here in our next class. What if I finish at half past? I think that should be fine. Just a few slides, but I don't want to rush the class. Okay, let's finish at 12:30. Then we'll stop wherever we get to. So the area of a triangle, you guys all know the formula of that. And we have different cases, okay? We have different cases where we can use different area formulas. We have, let's say, case 1 and 2. We're given 2 angles and a side of a triangle. Then we need to obtain the third angle. We can always obtain the third angle like we have been doing from this, using the fact that A plus B plus C is always equals to 180. Okay, then we can use, to obtain that, we use K. Remember, K is the area of your triangle to be equals to this equation. We will apply that in some examples. Okay. Another case will be given 2 sides and the angle opposite one of them in triangle ABC. A second angle is usually found by using the law of sines and the appropriate formula from case 1. Okay. In another case, which I call case 4, when you are given 2 sides and the included angle of triangle ABC, then you can use half AB sine C to obtain the area of your triangle, or half AC sine B, half BC sine A, as the case may be, to obtain the area of your triangle. Those are the 4 cases. Then the last case will be the Eros formula. How many of you, okay, yeah. So I would end the lecture at 12:30. Then you guys can self-study it. And if there's any question, you let me know. This Eros formula, which we also use to compute or calculate the area of a triangle whenever we're given the 3 sides of the triangle. Okay, and yeah, we have put in these soft examples. You should practice them yourself because you guys want to go for another class now. I need to round up. Then the final part of today's lecture is trigonometric equations. Okay, trigonometric equations. Basically, to solve trigonometric equations, we do not have a general method. Okay, there are so many methods to use in solving trigonometric equations. So what you need to do is look at the suitable method for that case, for that problem, and apply. For example, we can use factorable equations. Okay? And I think we have attempted some of these in our previous exercise, where we had to factorize the trigonometric, the angle given, and then we solve using addition or subtraction formula. So we can also use factorable equations to solve a trigonometric equation. If you look at this example, where we want to solve for x minus 2 sine x cos x equals to 0. The first thing I had to do is to factorize, okay? And then in doing that, since we have sine x in both sides of the function, sine x minus 2 sine x cos theta. So I get the factor out, which is sine x. I have it as 1 minus 2 cos x, which is equals to 0. Then I set each factor to be equal to 0. That is, sine x is 0 or 1 minus 2 cos x to be equal to 0. Then I solve for each equation. Okay? In this case now, I will be having my x to be equals to 0 to be equals to pi, or x will be equals to pi over 3 or 5 pi over 3. So here I'll be having 4 different types of different solutions, okay? And here what you just need to do is to be able to find that these solutions, do they really exist for that equation? What you do is you substitute your answer back into the equation. And if it gives 0, then you know that equation exists. That is what I mean by perform a check by substituting the values of x in the equation. So since you would have obtained different values of x, substitute those values back into the equation one after the other. The ones that do not give you 0 are not going to be the solution of that equation. When it gives 0, then that is the solution to that equation. It could be one value out of 4 to give 0, or you have 2, or every value 0, and that is how you obtain your answer. I've given other examples. I would want you to go through these examples, okay? And in our next class, you point out what you do not understand. Because of your next activity, I would leave you with this to self-study, attempt their classwork, and also answer attempt the assignment. In my next class, I would ask you to provide your solutions. Please attempt all of these assignments and classwork, okay? I think it's good time to let you go now. If you need tutorial, remember to chat up on WhatsApp group so that we can make provision for that. All right. And finally, your tests would be sometimes in June. Okay. I would want you to prepare well for it, revise the notes, the lecture notes, solve all the questions, and also try to solve more questions that you can lay your hands on. Then you'll be ready for your test. I guarantee that it's everything that you have been taught. That's what you'll be having in your test, okay? There's nothing's gonna come out newly from somewhere else. All right, guys, this will be the end of our trigonometric class. Our next class will be calculus, all right? I'll also, like I've always done, put out the notes before the class, and I'll expect everyone to go through the notes. Is there any question from someone before we leave? Any question? Can we call it a day? I'm not going to be giving you any extra assignments like I've always done. Your assignments are given in this lecture notes. Okay? Faith, do you want to ask any question? I would ask you for your assignment. Please attempt all the assignments that is in this lecture note. I've not asked you to submit, but I would ask you for the solution. Okay, thank you so much for